If it looks like a duck and quacks like a duck, it must be a duck. Find out what duck typing has to do with your programming on this week's MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week I want to talk about a few fundamental programming concepts that you may have heard thrown around and not exactly know what they mean. The first is duck typing, and this comes from the quote of if it looks like a duck and quacks like a duck, it must be a duck. What this really means is that in Python, unlike so many other languages, we don't really worry about what type objects are. We just worry about if the property we're interested in is accessible. So for example, if two objects have add methods that will work, then we use that add method. Or if you wanted to make a little example that had to do with ducks, you could create different classes, and as long as that class had a quack method, you would know how to quack that class. So let's take a look at what this would mean in practice. I'm going to create a simple function called combine objects. And it takes A and B. It returns A plus B. So if I call combine objects on two integers, we get the integer sum. If I call combine objects on a float and an integer, we get the sum as a float. Okay, so some programming languages might be able to do that without you doing a bunch of type checking. But what about this? We can take a string and another string, and it now knows that it can add those things together. And we're doing this all with one function with the single addition operator. Now, if all you've ever programmed in is Python, this probably doesn't seem that revolutionary. But if you were a programmer in C or Java or basically any other language, this is amazing. It does have limitations though. So what if I try to do this? Well, it says there's not an addition operator that's going to work for integer and string. I don't know what you want me to do here. So what should we do? Should we take everything that comes in to the combine objects function and make it be a float? Well, that's not very efficient if we're going to do it a bunch of times, and it may not always work. It may not always do what we want. It would, in fact, impede this capability of adding two strings. So this brings us to the next principle that we want to talk about. This principle has to do with fundamental design of code. In many languages, we use the look before you leap method, or LBYL. This is where we would specifically test, are both things coming into the combine objects function numbers? So we'd say, is it an integer? Is it a float? Is it a complex? Or if we're going to get something from a dictionary, we would say, if this thing exists in the dictionary, then we're going to get it. And you notice the key word in this is if. If you have a lot of if statements, it's probably because you're using a look before you leap architecture. Python is built around the idea of it's easier to ask for forgiveness than permission, EAFP. This means that we're going to assume that dictionary keys are valid. We're going to assume that the file that we're trying to open exists. We're going to assume that the two things that you gave our function are indeed things that can be added together. So this means instead of having a bunch of if statements, there's more try and excepts. And we've talked about try and except a few weeks ago in MetPy Monday. I encourage you to go watch that video. So let's take a look at how we would write this combine function in look before you leap and easier to ask forgiveness than permission. All right, so look before you leap, combine, which again, this is not the Pythonic way to do it, would be to say something like if type A is in the list of, or in the tuple rather, of integer, float complex, if type B, so we're checking both of our inputs here, is in int float complex. And remember, we're losing functionality here. We're not going to be able to add two strings now. I'm going to return a plus B. Otherwise, I'm going to return a type error. It says both arguments must be numeric. So if I call this with two numbers, it works fine. If I call this with a string and a number, we get our type error, except I don't want to actually return the type error. The proper behavior there would be to raise the type error. Okay, so that works. That's a lot of code. It's not very readable. You've got these double nested ifs. I don't really love that. Now let's look at easier to ask forgiveness than permission. So we've got our function. It takes A and B. I'm going to try to return A plus B. Except, remember, we want to only accept specific errors. Except the type error is E, I'm going to raise E. So this isn't a very exciting error handling case here. We're just going to raise the error that would have been raised anyway. But for a demonstration, it works well. So with two numbers, it works fine. With a string and a number, we get that we can only concatenate string, not int to string. Now notice, this is a bonus question. If you know the answer, put it down in the comments. There, our type error is can only concatenate string to string. And if we switch the position of the string, it's unsupported operand types for int and string. Why is the type error that's raised different? That's the bonus homework. But I hope you can see that by using these concepts of duck typing and easier to ask forgiveness than permission, you can create code that's more readable and that doesn't have all the extra bulk of type checking and input cleaning that we normally need to do in other languages. In this case, we assume that everything is going to work and just handle when it doesn't. One of the great things about Python. I hope that you found this useful. I'll see you on next week's MetPy Monday.